that is used in looking for the derivative of a function. And this particular rule is very interesting, because it's a composite function rule. A composite function rule. Let me give you an example. I don't want to start going into the theory. Let's give an example so that you understand better. Let's say that if you are given y to be equals to sine 2s minus 3. In this case, we can see that y is equal to sine 2s minus 3. Y is a function of angle sine. From here you can see that sine is a function of angle. This is an angle in trig, angle 2s minus 3. Of course, sine will be in radian. Now this sine is a function of angle 2s minus 3, and this 2s minus 3 is also a function of x. This depends on x. Sine depends on this. So we can say that sine is a function of another function of x. Sine is a function which also has another function. So when we are talking of function of a function, we are talking of a function of a function, we are talking of composite function, a function that has in it another function. So the rule that we use in computing, looking for the derivative of this type of question, is called the chain rule. So let's try to solve this. Anytime we have a function that are entangled inside themselves, more than one function. For instance, I can also have another question like maybe y is equals to 2s plus 3. And this is used to power 3. Now, this one inside, there is a function inside here. A function is actually operation. There's a function here. The function can be maybe a multiplication. There's a function of multiplication and addition here. And there's also a function of power here. These are two functions that is undergo, that this particular dependent variable will undergo. Because for you to find the value of y here, you have to multiply, you have to compute the bracket before you raise it to a power. So we are doing two functions there. That is, these two, any value of x, you multiply by 2, then you add it to 3. You have done a function here. Function is an operation that you compute on this. So, and the function outside also, which is raising it to 3, is also another function, which the composition of the two functions will give us this y. That is function of a function. Then for us to compute them, we use the chain rule. So let's solve this using the chain rule. How do we approach this using the chain rule? This is another question. We are not doing this. If you are to use the chain rule, I will use the quick method and I will use the explanatory method. But I'm going to start with the explanatory method so that you will not be lazy. Now, if I'm to use the chain rule for y is equals to sine 2x minus 3, what we do is that the inner function will be the first function. Yes, we're going to compute this also. You start from innermost. So you can say let your u equals to 2x minus 3. You will look for a variable that will hold on to this function. Okay? Then in that case, we can write our y to be sine u. From here, we can establish that our u is a function of x. From here, we can establish that our y is a function of u. The two functions. So the composition of the two functions, then the y, the s, is going to be the combination of these two functions. That is the u, the s, the u, the x, and the other one, the y, the u. The combination of these two functions will give us the y, the x. Of course, when you cancel this one out, you will see the y, the x as the function we are looking for. It's not very hard. So what we just do is to find the u, the x, differentiate u with respect to x. I can just do that one here. The u, the x is going to be what? 2. Then dy du is going to what? Cos u. Then we just say du ds is 2, dy du is cos u, and this is 2 cos u. You have to replace your u because it's a foreign member there. So you just have 2s minus 3. And that's all. So going to this question now, let's use another very fast approach to deal with this. When you say your y is equal to 2x plus 3 raised to the power of 3. I want to use the chain rule because the composite function that we have here, two functions combined together. We cannot put down two functions, so we can have three functions in a particular function. Three functions combined together. So using the fast approach to get your answer instead of using this method, this explanatory approach. What we do is that if you are to solve using the fast approach, we are going to start from the outermost function. What happens here is that we can use a power rule to take this one down. The y dx is going to be equal to 3, 2s plus 3 raised to the power of 2. But that's 3 minus 1, 2. Then we will now differentiate the innermost. When you now differentiate the innermost, you multiply it with it, and that's going to be 2. Then this is going to be 2 times 3, 6. 2x plus 3 is equal to 2. If you decide to use this approach, you must get the same answer. And that's the basic explanation of the chain rule. Let's continue.